Hey folks, Sega Sonic Fan here, and lucky you, we have another shaky camera laptop repair video. Woohoo! Yeah, sorry, I don't have a good camera that doesn't shake like crazy. And I don't have space to set up a tripod, so this is how it's going to be for a little bit. Anyway, working here on a MacBook Pro, and this one was very frustrating because I got it all repaired and ready to go, and then it had an issue. The first repair I did, though, was replacing this capacitor and doing some cleanup under this heatsink here, because what had happened is water had spilled from the top. Someone had spilled it in through the exit ventilation part. So if you spill water in the, towards the top of your keyboard, this is the area that'll be affected. Fixed all that, got it to boot up, chimed, played stuff well, everything was going good, but then I stopped getting sound, and there's a couple reasons for that. So one is I started getting the red light output on the headphone jack here, which is super frustrating, and that means that you're outputting digital optical sound, and that overrides everything. It's the SPDIF output, and so that means that you're not going to get internal speakers, and you're also not going to get analog headphones. So good luck, enjoying anything with sound after that point. And so I, did the usual, like, clean out the jack kind of stuff, and of course they didn't fix it, because that would be too easy. And if you look closer here, it turns out I had a larger issue, which really sucks, because this is an old board that was kicking around my parts bin, and who knows where it was before my parts bin. See if I can actually focus in on this, but right here, there is a bunch of BGA pads for a missing chip. That chip somehow broke off. I have no idea how or where it went, but it broke off. Fortunately, I didn't take any traces with it, but that chip is gone. So you're missing a chip, and you also have a SPDIF forced output. That's two really annoying issues. However, I think I can fix it, and I'm going to try to fix it. I'll make a part 2 to this, but let's first investigate what's going on. So, thanks to Bad Caps forums, I got the schematic and board view. People on those forums are freaking amazing. I'm always super grateful for their help. And if we look over here, the chip that's actually missing I found in the board view. I guess I'll show you that real quick. Let me zoom out and try to focus in here. I can't turn off the flash once I start recording, so that's kind of annoying. But anyway, go over here, and here is our board view software. This is Open Board View. There's some other softwares other programs you can use that are just as good, or at least competent. This one actually requires some pretty fast processing power, which is slightly annoying. But this is an i7, so it can handle it. Here's the chip, right here, U6700. And what does that do, U6700? You open your PDF viewer. Thanks to Louis Rossman, I did get Sumatra PDF. Highly recommend it, as he does for this kind of work. It's really great. And here is U6700 right here. It's funny that they say critical, because these things are not critical. Like, the machine boots and passes all tests without this chip. So Apple, why are you saying this is critical? It's not. It's just important if you want sound for your headphone jack. What this is it's an analog I/O switch, as it says right there. My guess is this is just like your typical I/O switch, like a 74HC 4053, which I use all the time. The old school 7.4 Logics. However, those have a high on resistance, and this one, because it's for analog audio, I bet you the on resistance is super low, and so it's just a nice, it's just a nice MUX. This is all it is. It's a nice analog MUX with probably a low on resistance. The chip number is MAX14560EWC+. And to my surprise, there's no datasheet I could source for that chip. I have no idea why that would be the case, and why Apple would want to keep this chip secret, because it really is a stupid chip. It doesn't do anything fancy. Even the GPIO pin over here is actually an input to the chip. It doesn't actually output any data. It doesn't communicate with the SMC in any special way. So unlike some of their specialized chips that are protected, this one, it doesn't make sense why that would be the case. So maybe Maxim just didn't want to upload it. I don't know. Even from Mouser, you can buy the chip, but you can't get the datasheet. Very strange. But yeah, so this is our chip. And what does it do, right? So it's just an I/O chip. What does that mean? Well, if you zoom in here,
trying to do this with my left hand since I'm holding the phone with my right. You'll see there's two common pins here, and there's NC, which means normally connected, not no connection, which is normally what MC means, but Maxim's weird. And this is kind of the new standard, I guess, for these MUXs, is NC means normally closed, and NO means normally open. Again, that's confusing because datasheets almost always NC means no connection. Don't ask me what they're doing. But normally closed, normally open. So normally closed goes to audio low amp out L and audio low amp out R. I'm not going to scroll up, but those basically come directly from the Sirius, the big fancy audio chip that's a DA, converts the codec. It's a codec, converts the digital to analog. And then over here we have our audio connector here, audio connect L, audio connect R. So obviously we just want that path to flow. But what does it also do? Well, it switches between audio LIL and audio LIR to that same connector, which is this is our headphone jack over here. So over here is our headphone jack. So what is this doing? In a nutshell, it is switching between a line input into your headphone jack or just audio out for your headphones. Thanks to Apple wanting to make everything, I don't know, compact, or I think it's really stupid, but what they did is your headphone jack on this thing, and again, we just looked at it earlier, it's that guy right there, or this dude. So that thing is just god-awful, in my opinion, because it's just doing too much, and it's going to fail. Maybe that's what they want, I don't know. But if you look over here, you have this, all three of these are for that jack. So you have a mic input, you have two detect lines, there's switch and detect, it's basically two detect lines, left, right, and you have SPDIF, your optical out, and then of course your shell, which is just grounded usually. Ground chassis. So this actually has multiple features. You have headphone out, you have line in, you have mic in, and you have SPDIF. So yeah, one of those is going to fail. It's going to happen. That's just too many pins. It's all mechanical. And of course, it's exposed to dust and other contaminants. So it's going to fail, which is the case in this situation. That's a pretty common issue if you look it up, actually. So, so the first thing I need to do, quite simply, is just, because this is just an I.O., and this should work, because it's literally just a switch. It's just connecting, this common to this when it gets the GPIO signal to do so. So when the SMC or whatever, whatever chip is doing it, tells it to switch, it does. And that's usually based on, when you plug in the headphone, something into the headphone port, it has a detect signal. Signal says, oh, you plugged in headphones. It tells this chip, turn it on, switch to the headphones. And part of that is based, I imagine, on it's measuring the resistance, the resistive load of your headphones. So if you're plugging in a line in, that's obviously going to be a much higher impedance than a pair of headphones, which are going to be like 32 ohms or something like that. So that's how it knows to do either line in or let the audio go out to your headphones. And so what I need to do is I need to do a jump from R6716 to the top of R6712 over here, and then the top of R6713 over to R6717. And that should just give me direct headphone output. I could replace this chip, but that is so much easier than replacing this chip. And all that does is it disables the line input, which I don't really care about. I don't think a lot of people care about that, doing a line input onto your laptop. It's good for recording stuff, I guess, but it's pretty uncommon. If you're going to record stuff really well anyway, you're going to use, a decent piece of audio gear, like an M-Box or something. So, yeah, so I could, torture myself and replace this, 10-pin BGA and reflow it and order the chip from Mauser and make sure, I do all that properly. But I don't really feel like doing that. It's a lot of work. So I'm just going to jump those two wires. And the other thing I need to do, thanks to Louis Rossmann, is he has a video where he talks about how to disable your SPDIF. Again, that's not a feature I want to use. It's not a feature people rarely ever use. And so he mentioned that R6805 is what disables that. So if we go over here and look at R6805, we can understand this more clearly, because R6805 is a 20 kilo ohm pull-up resistor, which is going to an audio sense signal, and that is going to a MOSFET right here, Q6801, and that is going to the audio sleeve detect. And sleeve detect is a good indicator of when something's optical or when it's analog, right? Because if you're using analog headphones, it's going to be metal. You're going to have a metal sleeve. If you're using optical, it's going to be plastic. And so that makes sense that that would turn on this MOSFET. And here it says audio port B, detect low. That's actually NC, it looks like, but oh no, it's probably going somewhere else. That NC is probably mislabeled again, meaning something else. But I'm not going to search around for it. I'm going to trust Louis Rossmann, and this all makes perfect sense. It also tells you, where is it? Oh yeah, right here. Port B detect SPDIF delegate. So simple enough. I'm going to remove that resistor. I'll show you where it is on the board. This is on my particular board. It'll be somewhere different on your board, likely, possibly. And in this case, the FET is this FET right here. That chip right there is the FET, and the resistor closest to the, this is your mic, this resistor right here is the 20K resistor. So I'm going to remove that, and that should disable the SPDIF, then add the 2 jumper wires, and then we should have working speaker sound and headphone port fully working with headphones, at the expense of sacrificing just digital optical out and line input, which I'm okay with. So stay tuned for part 2 of this video.